help me out here. Okay, so on a side note, no parallelograms will be killed in the making of this lesson. What figures can we find the area of now? Let's do a quick summary. What have we done so far? Max?
Rectangles, squares, circles, and triangles.
Rectangles, squares, circles, and triangles. Okay, good. If we go back to the very beginning of this stuff, we talked about area being how many little unit squares make up each one of these figures, yes? Yes?
Yes.
Good. So when we did a rectangle, we could divide a rectangle into all those nice little unit squares, and then that gave us this nice how many unit squares across the bottom versus how many unit squares going up the side. Bingo. We have the area of a rectangle. Rectangles are easy. We get into other shapes, it's not so easy. Circle in particular, you're not going to get squares nicely out of a circle, so we come up with these weird formulas. So I'm going to show you a parallelogram and where the formula from that parallelogram comes from. It's a little bizarre. Well, it's not a little bizarre. The method of getting the formula is a little bizarre, but the formula itself is nice and easy. Okay, so we're going to do something like this. We're going to take this parallelogram and we're going to drop in a height there. And there's a reason why I put it in the corner there. What do you know about these two segments here? What do you know about that segment and that segment? They're equal, they're parallel. Anything else? Those are the two that we need. So notice that I can measure this height anywhere between these two things. In fact, I can even come out here if I extend these sides, because that distance has to be the same because they're parallel. Okay. I chose to put it there for a reason. If I take any parallelogram, it doesn't matter what shape it is, as long as it's a parallelogram, big or small, tall or skinny, I can do this simple thing. And you're not going to do this when you're finding the area of parallelograms, but it will give you an appreciation for where this formula comes from. So I got to do a couple things here that you don't really care about. Just give me a second. Okay. So I'm going to take this little triangle over on the side. What can you tell me about that triangle, by the way? It's the right triangle, good. And I'm going to take this little right triangle here, and that piece, and that piece, and that piece, and I'm going to move it over there. Okay. Then take this stuff and hide it. And so we end up with that. Now, what can you tell me about that shape? Prove it. Okay. I just heard 26 people tell me it's a rectangle. We all agree it's a rectangle, but prove to me it's a rectangle, Mary.
All the angles are 90 degrees. We know that the top and bottom ones are parallel because
Okay, hold on, let's back up. Let's go step by step. How do you know the angles are all 90 degrees?
the bottom and top line are parallel.
Yeah, these are parallel, and we made that an altitude. An altitude, by definition, is going to form a right angle here. If that was a right angle when we started, then that had to be a right angle, because like she said, they're parallel. This right angle over here came from when we chopped it off of that end down there. This will work really good in the video, because we won't be able to see anything. But that's a right angle, and so by process of elimination, that chunk up there must be a right angle. Okay, good. So we got 4 right angles. Done?
No.
No? What else do we need, Jeff?
The top and bottom line are longer than the side lines.
Yes, but will that always be the case?
No.
Do we care?
No.
No, only in the aspect that it's a rectangle and not a square. Okay. So we have 4 right angles. We have the top and bottom are longer than the sides. What else do we need for a rectangle?
Opposites.
2 sets of parallel sides.
2 sets of parallel sides. Well, we already established that the top and bottom are parallel. How do you know the 2 sides are parallel? Max?
Because there's 2 90-degree angles on each side.
Beautiful. Okay. So we established that this thing is a rectangle. And how do you find the area of a rectangle? Base times height, correct. Here's our base. And that base is the same as that base. because when we started with the parallelogram, this chunk over here was actually over here, and those two would be equal. And then that would be our height. Same formula as same formula as a rectangle applies to parallelograms. Now there's a catch. It's not the side length. Remember, this was that original side that we had from the parallelogram. That angled side doesn't matter. We have to use the height as a vertical height. We need this guy. Got to be perpendicular to the base. Gesundheit. Okay. We good? And that's true with any parallelogram. I take any parallelogram, I drop a height from that upper corner, chop off that triangle, move the triangle to the other side. Bingo. We have a rectangle. Rectangle's base times height. Parallelogram's base times height. Problems? Okay. Good. Let's do the harder one then. Let's put a dot there. Okay. Let's try that again. I don't want to say. All right. Trapezoid. Kev, what can you tell me about that trapezoid?
The top and the bottom, they're parallel,
Good?
but they're not equal.
Good. Can't be equal because then we'd have a parallelogram. Okay? So top and bottom are equal. Or sorry, I'm stupid. The top and bottom are parallel. Anything else?
There's no right angles.
There's what?
There's no right angles.
Can there be right angles?
Yes, they could.
There could be. Well, you gotta be careful how many. You get too many in there, it all of a sudden turns into a rectangle and you've got a whole world of hurt. What do you wanna share with us?
I was looking to show anything.
You're just waving your hands around in the air like you just don't care?
Yeah.
Okay, beautiful. Designated the two bases as B1 and B2. The top one is B1, the bottom one is B2. It doesn't always have to be that way. You could put B1 on the bottom, you could put B2 on it. It doesn't matter. Okay. But they're different, like Kevin said. They have to be different, otherwise we don't have a trapezoid. And then I drew the height in there. And that height can be anywhere. Let's see if this works. Nope, that didn't work. I didn't want to do that. Edit, undo. I think maybe this one will slide off. There we go. So I can slide that height anywhere along those two bases, which is the same thing I could have done with the parallelogram. Because I'm measuring that distance between the parallel lines. Okay. So what if we take the parallelogram approach to this problem? What if I move this height over here, and I chop off that triangle and put it over on the other side like I did with the parallelogram? Will that work? No, not even close. So I have to come up with a different technique. So this is the different technique that we're going to do. I'm going to take that trapezoid and duplicate it and flip it over. So I get it this. So this puppy is the same, it's a little hard to see there because I'm running out of space, but it's the same trapezoid. I just flipped it over, and if I slide it over here, now what do I have? We pretty much covered all of them. What shape is that big whole object now? It's a parallelogram.
And then you take the triangle.
Yeah, then I could go through the same process. Okay. We know what the formula for a parallelogram is now. It's base times height. However, that warrants a little bit of discussion here. Looking at this big purple parallelogram, I need the length of the base. How long is that huge base? What's that? I didn't hear what you said, that's all.
It said B3.
We can call it B3 if you'd like.
B2 plus B3.
B3 works fine for me. How long is the top base? Well, we don't care about top base because it's a parallelogram now. All we care about is the length of the base times the height, which we already called h. So therefore, the area of this big purple thing would be B3 times h. Okay. And Max, I think you said it. How else can we write B3?
B2 plus B1.
Good. I'm going to do B1 plus B2, same thing. Everybody with me so far? One more step. That's the area of the whole big purple thing. But that big purple parallelogram is made up of what? Two trapezoids, which we want to find the area of only one of them, so what do I have to do with that formula? Divide by 2. Right. So the area of that trapezoid is 1/2 B1 plus B2 times H. And again, these are purely derivation techniques. Every time you go to find the area of a trapezoid, you're not going to duplicate it, flip it over, measure those things, and go through that whole process. But that's where these formulas come from. I'm not a big fan of just giving you formulas and go memorize formulas, regurgitate them later. So now, other than probably the circle, we can talk about where the area formulas come from for all of them. Okay, rectangle, for instance, I already talked about having a bunch of unit squares going across, a bunch of unit squares up. The total number of unit squares then is the length times the width for the number of unit squares. Bingo, we got a rectangle. Circle one we didn't talk about so much. Triangle.
We only did like a couple days on it.
Okay. Triangle, we could have done the same technique we used on the trapezoid. If you take a triangle, duplicate it and flip it over, you end up with a parallelogram, and then you do 1/2 base times height. That's where that one comes from. I probably should have done that. Did I do that with you, or was that Cusick? She did. Okay. So, but then again, that's another technique that shows you that triangle formula. What do we have left? What haven't we talked about? Kites, rhombus.
Did we talk about circle or?
Yeah, we did.
Yeah, we did circle. We'll do more with circles because we'll start taking chunks of circles soon. We'll do things called sectors and segments in a circle. Oh, they're fun.
Is the
Good times.
set Friday gonna be on all these, all the shapes?
Just up to the ones we've covered.
Find circles in
So today's Wednesday, right?
Yeah.
Yeah, tomorrow, I haven't looked at the assignment sheet. I think we're doing rhombi and kites tomorrow, but I don't think they're on the quiz. I'll let you know. I think it's up through this stuff.
Oh, yeah.
Okay.
Yeah.
Got it? Any problems? Beautiful. Doesn't matter which one B1 or B2 is. And notice there are 4 unknowns in this equation. You should be able to take any of the 3 and solve for the 4th. Does that make sense? So for instance, we'll look at an example here of the trapezoid. Let's suppose you know that B1 is 10, B2 is 14, and the height is 5. Go ahead and calculate the area of that trapezoid. We'll do the easy one first. For units, let's use centimeters. Okay, should have 60, yes? Okay, what does that look like? 1/2 B1 plus B2 all times H. So 1/2 10 plus 14 quantity times 5, which would be 24 times 1/2 is 12 times 5 is 60. Units here? Centimeters squared. Okay, that's the most basic trapezoid calculation. Now let's change it. Let me get rid of some things here. Let's get rid of this stuff. And then let's do, let's try this. We'll put the 14 back in there, change my mind. And let's say the area is, we'll use a number from the problem yesterday, 212.5 centimeters squared. What's the height? Don't expect this to turn out to be a pretty answer because I just randomly picked numbers. It seems that the general consensus is 17.71. Yes? Some of you not so much? All right, let's try that, see what happens. Starting with the formula again and plugging in what we know. 212.5 is equal to 1/2. What's B1? 10. What's B2? What's the height? H. Well, that's supposed to be a 1 there. How are you going to solve that? What do you do first? Add the numbers in the parentheses would be a good idea. Now what? Couple answers here. You could do this a couple different ways. How many of you took 1/2 times 24 now? Okay, good. How many of you multiplied both sides by 2? Okay, both of them work. Since most people took this, then I will just leave this as 212.5 equals 12H. So therefore H is equal to, what do we say, 17.7?
But you divide 12 to 12.5, right?
Correct, yeah. Okay, problems there? Let's look at the third scenario then. Get rid of this stuff. We're not going to do the height. Get rid of that, get rid of that. This out. Do, 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 do. Is that bothering anybody, by the way?
No.
Come on.
Yes.
Yeah. Bothers me too. I gotta get rid of it.
Oh, that's not you're humming.
Okay. What'd you say?
I thought you were talking about your humming.
Oh, no. I don't care if that bothers you. Let's put the height as 7. And Sterling, what year were you born?
2003.
2003. Which, if you add those digits together, is 5. And you have how many people in your family?
4.
4, that's 20. And what's your street address?
782
So 718 divided by 20 would be 359.5.
Should be
9.
I'm sorry, what?
It's 35.
35.9.
Oh, yeah, that's what I meant. Just seeing who's paying attention. Okay, solve for the other base. So this is 7, and that's B2. This works out nicely. That will look like a triangle.
I got your, I'm also missing a calculator, so I'm just gonna.
I got
0.257?
I got
Oh.
that. I got that.
0.257?
Yeah.
I think with a calculator I would have gotten that. Yeah, I think I did the work right, I just
Great.
don't wanna figure it out.
If I was 7'2", I think I would have made it in the NBA also. Anybody else? 0.257? All right, other answers, what did you say? 11.95, anybody? Okay, that's all right. Well, any other answers? I'm guessing probably 0.257, which is a weird answer.
I got
Yeah, I did get 0.257.
You did, huh?
Wait.
How
no,
convenient.
Never mind. I thought you were still.
10 plus B2 equals, or times 7. Okay, how do you solve that? What did you do first?
No, I'm good.
Multiply by 2.
Okay, so how many people started by multiplying both sides by 2? Raise your hand. How many people took 1/2 times 7 to start? Okay, how many people distributed the 1/2 to the parentheses? Okay, how many people distributed the 7 to the parentheses? Okay, so now you see, we've got, that's at least 4 different methods to solve it. Yeah.
I redid it and got 2.57 or 0.257.
Ooh, jumped on the party wagon, okay.
I got 2.5.
I personally would multiply both sides by 2 to get started. So that would give me 71.8 is equal to 10 plus B2 times 7. Okay. So who did this first? All right, what'd you do next? Did you divide by 7 or distribute? Divide by 7, distribute, distribute, okay. Seems to be the consensus is distribute, so I'll do that. Oh, now I see why we get such a weird answer. Probably should have just gone with your address instead of all the other manipulations. But, okay. So what does that trapezoid look like?
Weird.
Max?
When you multiply by 2 on both sides, the 1/2 is canceled out, right?
Correct. Yeah. And that's why we do it to get rid of the fraction. Okay, so those are the possibilities there with a trapezoid. The other one, the parallelogram, 3 values should be pretty easy to solve. If I give you the base and the height, easily find the area. If I give you the area and the base, you can find the height. If I give you the area and the height, you find the base. Okay, we good? Any issues? Remember, on the quiz Friday,